Hey guys, welcome back to the channel. If you're new here, hit that subscribe button and ring the bell. Because today, we're talking about a story that's shaking the entire car industry to its core. Let me set the scene for you. Back in April, a Chinese car company called Geely dropped a press conference that made engineers around the world spit out their coffee. They put a number on the screen, 48.41%, and let me tell you, this isn't some random stat you can ignore. This number was supposed to be physically impossible. Not hard, not too expensive, impossible. Like, engineers have spent over a century saying this couldn't happen. Let me break it down for you in plain English, no fancy jargon. When you fill up your car with gas, most of that energy you're paying for just vanishes. It goes out the exhaust as useless heat, soaks into the engine block, or gets wasted in all the metal parts grinding against each other. Think about it, a top-tier car from Toyota or Volkswagen. You know, the ones everyone thinks make the best engines. Only uses about 30% of the fuel's energy to actually move the car. 70%. Gong dot wasted, dot poof. Just heat that does nothing for you, your commute, or your wallet. For 100 years, engineers have been trying to shrink that waste. And the best any mass-produced car engine ever got was 41%. Toyota celebrated that number like they'd landed on the moon. They spent billions of dollars to get there. And they told the world it was the ceiling. Like, this is as good as it gets. Going higher would cost more than it's worth. And it's basically against the laws of physics. Then Geely rolled up and walked past that ceiling like it was a wet napkin. 48.41% officially certified, measured, and even recognized by Guinness World Records. This isn't a small step forward. This isn't a software update. This is like if someone invented a plane that flies faster than the speed of sound. But everyone thought planes could only go 50 miles per hour. It's a whole new universe of engineering. And the wildest part? It's not even the number itself, it's how they did it. We're talking about a tornado inside the engine cylinder. An engine that runs hot and cold at the same time. And an 11-inch -1 machine that looks nothing like any engine you've ever seen. But before we get into the cool tech stuff, let's make sure you actually get why 48% is so absurd. Because to understand that, you need to know why 41% was supposed to be the finish line. Think of a combustion engine like a campfire stuffed inside a metal box. You throw fuel in, it catches fire. The explosion pushes a piston down, and that motion turns your wheels. Simple enough on paper, right? But here's the problem. Fire makes a ton of heat, and heat doesn't care about your wheels. It wants to spread everywhere, into the metal walls, the air around the engine, out the exhaust. The engine is constantly fighting to keep that energy pointed in one useful direction. And it loses most of that fight every single time. There's a physics rule called the Carnot limit. You don't need to memorize the name. But here's what it means. There's a hard mathematical ceiling on how efficient any heat engine can be. It depends on how hot your explosion is versus how cold your exhaust is. The bigger the gap, the more work you can get out of it. But there's a catch. Make the explosion too hot, and you melt your engine. Keep the exhaust too cold, and your pollution control stops working. For decades, engineers at Toyota, Honda, BMW, and Volkswagen treated 40% like a brick wall. Going from 35% to 41% took billions of dollars and decades of tiny, incremental changes. Toyota got there with a trick called the Atkinson cycle. Fun fact, it's not even a new trick. It was invented back in 1882 by a guy named James Atkinson. But Toyota refined it for modern cars. The idea is simple. You leave the intake valve open just a tiny bit longer than normal. That small change cuts down on wasted compression energy and squeezes out a few extra percentage points of efficiency. When Toyota hit 41% with their 2.5L dynamic force engine, the whole industry stood up and applauded. Engineers wrote papers saying going much further was practically impossible at any reasonable cost. The common wisdom was, why bother? Electric cars are the future anyway. Let's just phase out gas engines. Turns out, that was one of the most expensive mistakes in modern car history. While Western automakers were betting their entire companies on fully electric cars, don't get me wrong. EVs are great, we'll talk about that later. Engineers in China were asking a different question. What if we just start over from scratch? That question led to the first crack in the wall. And it came from a company you probably already know, BYD. Before we talk about Geely's 48%, we need to talk about 46% because that's where the story really starts to shift. BYD, which stands for Build Your Dreams. By the way, looked at the traditional hybrid car and said, this design is outdated. In a normal hybrid, the engine and electric motor both drive the wheels at the same time. The engine is constantly changing speeds, revving up on hills, slowing down at stoplights, shifting gears through a complicated transmission. Every time the engine changes speed, it drifts away from the sweet spot where it's most efficient. BYD had a better idea. What if the engine didn't drive the wheels at almost of the time? What if it just stayed at one perfect speed and acted purely as a generator, making electricity? The wheels would be driven entirely by electric motors. And the engine would only do one job, run at the exact RPM where it works best. No compromises, no trade-offs. That's their DMI system. And on their 5th-gen platform, it hit 46.06% thermal efficiency. The global car press was stunned. A 5% jump sounds modest, but let's put it in perspective. Toyota took roughly 20 years and billions of dollars to go from 36% to 41%. That's 5%. BYD did it in a fraction of the time with a totally different approach. Legacy automakers panicked a little, then went back to their plans and told themselves, this is just a regional thing. Western consumers won't accept it. Sound familiar? They said the same thing about Japanese automakers in the 1980s, and we all know how that ended. Hint. Japanese cars took over the market. But here's the kicker. While the industry was still processing BYD's 46%, Geely had already been working for 2 years on something that would make that achievement look like a warm-up. And the key to what they built starts inside the engine cylinder, somewhere no one thought to look. Let's talk about the tornado inside the engine. This is where things get really wild. Geely's new IHEV system didn't just tweak existing engine design, they threw out the rulebook on how air and fuel mix inside a cylinder. And this one change is a huge reason for that record-breaking 48% number. Here's the problem with normal engines. When air and fuel get pulled into the cylinder, they don't mix evenly. Imagine pouring cream into a cup of coffee without stirring it. You get uneven swirls, some spots thick with cream, some mostly coffee. Same thing in a traditional cylinder. Pockets where the mixture is too rich, too much fuel, not enough air, and pockets where it's too lean, too much air, not enough fuel. When the spark plug fires into that uneven mix, the flame doesn't spread all at once. It starts at the spark and creeps outward like a wave. While that wave is crawling across the chamber, heat from the first burst of flame is already leaking into the metal walls. By the time the whole mixture burns, you've lost a ton of energy to the engine block itself. That wasted heat is one of the biggest reasons traditional engines can't get past 40%. Geely's engineers fixed this with what they call the Yufeng tornado combustion system, or just the fire tornado for short. They completely redesigned the shape and angle of the air intake channels. When the intake valve opens, the incoming air isn't just pulled in passively. It's forced into a high-speed spinning vortex. A literal, controlled tornado inside the cylinder. When the spark plug fires into that spinning tornado, the flame doesn't creep, it explodes outward in all directions at the same time. Why? Because the fuel and air are perfectly blended from all that turbulent spinning. The combustion is sharp, clean, and synchronized. Almost all the energy goes straight down onto the piston, before the heat has a chance to leak into the walls. Less wasted heat, less pollution, more force on the piston, more efficiency. Perfect, right? Well, not quite. There's a catch. Cranking up combustion like this creates a new problem: engine knock. That's when fuel ignites before the spark plug fires, creating an uncontrolled bang that can crack pistons and destroy an engine in minutes. Solving the knock problem is what kept engineers stuck below 41% for so long. And Geely's solution? Just as clever as the tornado itself, an engine that runs hot and cold at the same time. Every engineering textbook will tell you, running a combustion engine at extreme compression and extreme heat is a one-way ticket to catastrophic failure. You can't push the explosion harder without risking destroying the engine from the inside. That's the wall. That's why no one cracked 41% in a mass-produced engine for over 20 years. Geely's answer? Make the engine run hot and cold simultaneously in different zones on purpose. In a normal car, the cooling system sends water through the entire engine at roughly the same temperature. It's a one-size-fits-all compromise that works okay. But it treats the top of the engine where the explosions happen, and the bottom where the pistons slide. Like they need the same thing. They don't. Geely split the cooling system into two completely independent zones. The cylinder head, the very top of the engine, where the explosions happen, is kept extremely cold. Coolant flows fast and aggressively through this zone, pulling heat away the second it appears. Keeping the top cold means the air charge stays dense and cool right up until ignition. That prevents premature detonation engine knock and lets the engine run at a way higher compression ratio than normal safer. More compression means more energy from every explosion. Meanwhile, the engine block down below, where the pistons slide up and down thousands of times a minute, is kept deliberately warm. Why? Because warmth thins out the engine oil. Thinner oil means the pistons slide with way less friction. Every tiny bit of friction you eliminate is energy that reaches the wheels, instead of being wasted as heat from metal grinding on metal. So you have one engine, cold at the top to allow massive compression, warm at the bottom to minimize friction. In traditional engines, these two goals directly conflict. Geely built a system where both happen at the same time, in different parts of the same engine. An electronic water pump manages it all, reading engine conditions dozens of times per second, and adjusting coolant flow instantly. It sounds like it shouldn't work, and that's exactly why it does. No one else tried it because conventional wisdom said the trade-offs weren't worth it. But even the most efficient engine ever built is only half the story. Getting all that energy to the wheels without losing it in a complicated gearbox is the other half. And what Geely built to solve that? Just as revolutionary. Let's talk about throwing the gearbox in the trash. Even a 48% efficient engine is useless if you bleed that efficiency away fighting through a heavy, complicated transmission. Traditional automatic gearboxes are mechanical masterpieces, but they're heavy and full of friction. An 8 or 9-speed automatic has hundreds of moving parts. Clutch packs, hydraulic torque converters, shift forks, synchronizers. Every single one of those parts soaks up a little bit of the energy you worked so hard to generate. The whole system can weigh over 100 kilograms. And it still wastes a meaningful percentage of the engine's output before the power reaches your wheels. Toyota's hybrid system uses something called an ECV-TIA, planetary gear set, that was revolutionary back in the late 1990s. But it's over 25 years old now. It adds weight and complexity that modern hybrids don't need. Geely looked at all that and started with a blank sheet of paper. What they built is called the 11-in-1 EDHT, Intelligent Drive System. It's not a gearbox, it's an electromechanical power router. It packs the engine, generator, 2 electric motors, high-voltage inverters, and thermal management hardware all into one compact housing. The total powertrain weight dropped by 13.5% compared to traditional hybrids. No shift forks, no hydraulic fluid channels, no torque converters. For about 90% of your daily driving, commuting, running errands, the combustion engine has zero physical connection to your wheels. It runs at its perfect efficiency sweet spot and powers a generator. That electricity goes either to the battery or directly to the electric motors spinning the wheels. From the driver's seat, it feels just like a fully electric car. Silent, smooth, instant torque the second you press the pedal. The only time the system connects the engine to the axle is at steady high-speed highway cruising around 80 miles per hour and above. At that speed, routing power through electric motors actually wastes more energy than a direct mechanical connection. So the system automatically detects that and locks the engine to the wheels like a top gear, bypassing the electrical conversion entirely. Managing all of this is an AI system that recalculates the most efficient way to route power 50 times every second. It reads your navigation, sees a hill 3 kilometers ahead, and decides in real time, charge the battery now and coast down the other side. Or use the battery now and let the engine recharge on the descent. It's thinking about your entire journey in a way no human driver ever could. The result of all this, the fire tornado combustion, the split thermal zones, the 11-inch -1 drive unit, and the AI power routing, is a certified fuel consumption of 2.22 liters per 100 kilometers. That's a Guinness World Record for production vehicles. On a full tank, you're looking at a range of over 2,000 kilometers. Let that sink in. A full-size SUV that burns less than 2.5 liters per 100 kilometers in real-world conditions. That changes everything about what a car can be. Now let's talk about what this actually means for the rest of the world. Let's be honest, pure electric vehicles are great, silent, efficient, zero tailpipe emissions. But they come with real trade-offs that millions of buyers aren't ready for yet. A large electric SUV needs a battery that can weigh over 500 kilograms. Charging infrastructure is still thin in huge parts of the globe. And range anxiety? It's a real problem for people with real lives road trips, long commutes, no access to home charging. Geely's IHEV system is a different path through the transition. You get the smooth, silent, instant torque commute of an EV for daily driving. But you have over 2,000 kilometers of range. You can fill up at any gas station on the planet, no need for a charging network. And the fuel cost per kilometer is comparable to an EV in most markets. And this isn't a tiny, lightweight commuter car, it's a full-size SUV. That's a game changer. For Western and Japanese automakers, this is a huge challenge. The combustion engine was invented in Europe, Germany, France, Britain, dominated it for over a century. Japan refined it to what everyone thought was near perfection over 50 years. Now, the record for combustion engine efficiency belongs to a company that didn't have a serious global presence 15 years ago. Closing that gap isn't done with a firmware update or a new ad campaign. It requires rebuilding engineering teams, asking different questions, and funding years of research. That's hard when your investors are pushing you to go fully electric, and your combustion tech is falling further behind. But for consumers, this competition is great news. History shows that when engineering ambition like this enters a market, prices drop and technology improves across the board. Legacy automakers will eventually respond. The question is how much ground shifts in the meantime. What Geely proved, beyond any number, is that the combustion engine still has enormous life left in it. The limit was never the laws of physics. It was the limit of what people believed was worth trying. If you made it this far, you now know more about engine efficiency than most people who write about cars for a living. That's pretty cool. If you found this useful, hit the like button, subscribe, and ring the notification bell. You don't want to miss our next breakdown. We're going to keep following this story as legacy automakers start to respond. And that's going to be fascinating to watch. Now, I want to hear from you. Do you think the 48% hybrid is the smartest bridge to a fully electric future? Or do you think EVs will leapfrog all of this faster than anyone expects? Drop your answer in the comments below. I read every single one. See you in the next one, guys.